Welcome to On Cloud, the podcast for cloud professionals, where we break down the state of cloud computing today and how you can unleash the power of cloud for your enterprise. Now, here's your host, David Linthicum.
Hey guys, welcome back to the On Cloud podcast. And the show I'm joined by Josh Hilliker, Principal Engineer, Senior Director of Cloud Solutions at Intel. Josh, welcome to the show.
Right on. Thank you, Dave, for having me.
So what does a Senior Director of Cloud Solutions at Intel do? What's the day in the life of Josh like?
Boy, there's so many things. So understanding what's happening in the cloud native tools, what's happening with our customers in this space from onboarding and repatriation from the cloud, and then for what partners need and want. So it's kind of looking at the entire ecosystem, what's available, what's out there, where can Intel lend a hand to help them in their cloud journey. So yeah, the day's a busy day.
So what kind of tools and solutions, technology are you normally dealing with on a daily basis?
Yeah. So as I look at the cloud, right, and see, from what hardware, software, and availability is there, the tool set around that is, what are my transition points, my activities into the cloud, right? So when I look at cloud native tools, I'm thinking about, okay, what's doing recommending whether it's cloud to cloud, cloud to multi-cloud, cloud back to on-prem with repatriation. But it's like, what are the recommendation tools? The next step I'm looking at is what are the provisioning tools? So the creation. Back in the on-prem days, I just absolutely loved provisioning, creating it up from base, nothing, the full, OS, BIOS, everything. That creation stage still exists in the cloud, still super important on how do you do it? What are the BKMs? And then the next area is that whole, kind of modernization, changing, updating, refreshing, being mindful of, different architectures, mindful of different software packaging when things get updated, when new roadmap items happen. And then the last, and we'll talk a little more about this last one, but is governance. It's compliance. It's, what's really happening? How's the drift? How much drift? What has been changed? And having that kind of compliance. So as I look at the tools, I'm looking at those 4 different transition actions to see what's in the market, who's out there, how do we work together, and how do we make it a easier journey for both customers and partners.
So you have this concept of optimization, certainly as an architect, I use it a ton, talk about getting to the most optimized architecture, which means that we're trying to build as much efficiency as we can in it. And it means different things to different people. So when you deal with optimization, leveraging technology to do optimization and optimizing systems, how do you define it? And what does it mean to you specifically in terms of how it's going to be implemented at Intel?
Yeah. When I look at the word optimization, I'm thinking about workload optimization. And specifically, we've been looking at workload optimization as code. So what is the workload? What is the stack? What is the hardware layer underneath? And then what that translates from a activity and what we're doing is, what are the different tunables? What knobs are available to tune to make it more optimized? So if it's, how am I handling buffer? How am I handling cache? How am I handling queue links? How, basically all those different tunable knobs and saying, how do I tune it in based on the workload and based on the use case? How is it being leveraged for that specific customer or that specific industry? So that's how when I look at optimization, that's how I'm looking at the workload. What is the workload? Is it, MySQL database? Is it Oracle? Is it MS SQL? Because it's in that data family, or is it an AI workload? And kind of what are all the tunables and how do I dial that in?
So this is kind of a dynamic concept at this point. So in other words, there's optimization. We think about almost like tuning an engine. So we're going to put, different points and plugs and make the engine run as best of it possibly can, and therefore it's fully optimized. But workloads are a different beast because they're going to change behaviors and change usage patterns and change different ways in which they're leveraging data and different ways in which they're leveraging the processor and the network and those sorts of things many times while they're running, and therefore the optimization or the tunables are going to change over time. So how do we deal with that?
Great question. And that brings up another part of my history as well, is the robustness of telemetry matters. and knowing your performance matters and being able to keep track of it with the right level of granularity based on what's happening. So when we start looking at workload optimization as code, it's like, okay, what the starting point? What should it be? What are we seen as the BKC, best known configuration? So optimization code is what are the different configurable parameters? There's service optimization, there is cost optimization, and performance optimization. I am looking, when we say optimization as code, we're looking at the cost and the performance element of it. Of how do you, cost is like, are you right sized? You have the right kind of the right configuration and the right hardware platform for the workload. And then on the performance side, it's like, have you truly, dialed that workload in to operate the most efficiently possible? And then those all lead to, of course, a better service to the end customer, whether it's patient care, whether it's booking interface, what have you. It's being able to tune those correctly. So when I look at optimization, I'm looking at the whole stack, from hardware, software, middleware, runtime, app, experience.
So listeners are probably asking the question, heard of infrastructure as code? So how do we get from infrastructure as code to optimization as code? And what are the differences and what things do I need to consider as I kind of use both concepts?
All right, so let's take that stroll through IAC and where we're at today. So infrastructure as code, great movement. Absolutely seeing more and more companies go after that, where they're codifying the infrastructure so that it's got better predictability, better reliability, less human error, and teams can all work together to revision their infrastructure in a way that I'd say is more, it's more scalable. It's more aware of what they're doing. So infrastructure as code is that kind of that first big move. The next big move is really the policy as code. That's about 1.5 to 2 years old, of how do I govern in a whole different way. So initially policy as code, we had thought a lot about, ports and protocols, and am I shutting down SSH? Am I making sure that I'm restricting, everything from 0.0.0, right? It's like, am I restricting all that correctly? But policy as code has really morphed into a different level of governance of, am I applying the right workload to the right infrastructure? Am I applying the right tunables? Am I thinking about this the right way? And that's that pack journey that is, again, by 1.5, 2 years old. This is the next progression of writing optimizations into code and making it so that it's the same kind of repeatable with IAC, executed through pack. So there's this formal relationship with the two. Now, in contrast, when we started the journey on optimizations, we would provide everything in a PDF. It would be a kind of a, anywhere from, 40 to 80 to, a couple 100-page PDF of, here are the optimizations. Here's what they all mean, point by point. Here's what that parameter does when you tune it. Here's how you would tune it. And it goes through that. That is not optimization as code. Now, taking that PDF, transition it to a code set where I can do an automated recipe, a deployment module, and putting those pieces together is what optimization as code really is all about. It's like, how do I get it in a way that the easy button is there, the ability just to say, I want this optimized as a starting point and be able to pull from that right at the gate, not let's go figure out how we tune it later, or, hey, I'm having a performance issue. How do I configure this? No, you're doing it right from the start. And that's kind of, to me, the migration, or kind of this journey we've been on around the ACs, right? Of IAC to PAC to OAC.
So I got to ask the question, is AI applicable here? Is AI helping us optimize systems? And if so, how does it kind of fit in?
So AI, there is absolutely a role with AI in the space. The first thing is the tunable parameters. How we've done that in the past is we have workload owners that really know their stuff. They know what's going on with the workload. They know all the tunable, what I can do inside the software, what I can do for the database engine, what I can do for the hardware. And we have brought AI in on top of that to really push the system and say, okay, what else? What else? What other permutations, combinations, and what is the BKC, the best known configuration? And so we've used AI to really tune these parameters in. So when you look at an optimization as code module and a recipe, it's actually the output of using both the human startup and AI to make that possible. And so as we're looking at new workloads, we're using AI to help us with What are the tunable parameters? How much do I tune it? What are the ratios? What should that configuration be for the different level of services, right? The landing zone. So like, am I doing bare metal as a service? Am I using IaaS? Am I using PaaS, et cetera? It's like, where's the landing zone? What are the tunables? And AI plays a huge role in making that possible.
Right. It's able just to look at a lot of information and tell us the gist of it. And therefore, some people who are doing the optimization of code, it just kind of makes that job easier.
Yeah, it does. For those that are tuning, it helps, right? What I'd say is we start with a tuning place, a workload expert. It comes in and fine tunes out a whole, I'd say, deeper breadth of tunable parameters, right? And the amount of combinations it can run is humanly not possible, right? It would take us months. Instead, it's like minutes and hours. Say, okay, here's your best known configuration. And we apply that into the optimization as code.
So what are business benefits? How do we explain this to a CEO or a CFO or, people that are concerned about, you're going to spend so much money on doing this? What kind of business benefits can we realize from this activity, from this concept, from moving forward with these concepts?
Yeah, I believe that in the cloud space, we are all still moving through the big kind of shock and awe of how much does it cost, right? How much does the service really cost? Oh my gosh, auto scaled and that now 2x, 3x my bill. And so there's this, how should I be running the cloud? So from a business standpoint, it's like, how can I move my development team faster, keep them going on the product front, but optimize my infrastructure so I can lower costs, increase performance for them. And that's where, to me, optimization code fits right in. It's like, we can help with the development time, right? Help with the automated recipe, help with the deployment module, be able to give you things where you're not reading a bunch of documentation, you're not spending all those development costs. I mean, what I like to say is that if the level of effort is greater than the ROI, why do it? And that is where optimization code fits right in it. We're going to help decrease the level of effort so you can focus on your time to market of your product. You can focus on other use cases of your product because we're giving you the ability to get the easy path or easier path to this. So there's that benefit right there from a C-suite standpoint of saying, hey, it works this way. So to me, that is number one. The other thing is that for customers that, hey, we for CFOs are saying, hey, I've got a mature business and it's going well. And I've already got all this infrastructure as code. I've already got my DevOps and I've already set this function. And I don't see you guys can help. Well, guess what? In optimization code, we have got, the right brownfield hooks where you could take current infrastructure, not redo it, but add in those optimizations and be able to get to that next state. So again, back to that squeeze, shock and awe, the squeeze of the bill. It's like, no, you can see this will improve your performance. This will lower your cost, even in brownfield. And then as I was out talking to customers this last week, some of the things I heard was optimization, automation is invaluable for the industry from a C-suite player. I said, this is, where we're going. This is where the industry's going. This is where we are headed. And it's great to see that we're going down the space. Now, another part, back to the CEO and even the CFO is that the world of provisioning and creation in the cloud is starting to migrate even more to machine communication, where machines are talking about placement. Machines are doing it. They're setting it up. They're repositioning. They're reprovisioning. They're making sure that auto-scaling is correct. And the preparing ourselves for that is super important. And so if we can, as Intel, we're providing the building blocks, like here are the modules that will help you when that machine-to-machine communication gets to that 100% marker. This will help you from a scaling correctly, scaling back correctly, being able to understand what the next architecture is and the immediate benefit of a next architecture. Because in a lot of cases, it's going to cost you less to move to the next architecture. That should be something that you don't have to think about. It just works. It just does the job for you.
Yeah, I think there's a pent-up demand right now. If you look at 2022, it was one survey after the other where people were just very shocked at what they were paying for cloud-based systems and even some infrastructure. I mean, some on-premise-based stuff as well. And so in other words, we moved massive amounts of things during the pandemic and prior to that, and say at 30-40% of the applications and the workloads existing on the cloud. But the bills that came back from these systems was way out of whack than what people expected. And if you look at it, it was more self-inflicted, and a lot of the stuff was grossly under-optimized. Do you think that's a use case for this, the ability to get those things under control?
Absolutely. And grossly unoptimized is absolutely right on par. It is vanilla configuration is of yesterday, right? You got to dig in a little bit more. And it's not just recreational digging in, but digging in because of that cost benefit, because of the performance benefit. And, we live in a two-pronged world in my mind. It's cost performance. I want performance great, but I got to look at cost. So yeah, for how services were ran, how they were configured. One of the most, kind of frustrating points that customers send me is, hey, I auto-scaled and I didn't need to. And it's like, yeah, and how much that cost you? Like that shock. So now, as we went through the pandemic, as that push to the cloud, and there was this I don't want to say Wild West, but it was like, hey, everybody go fast because we got the employees at home, we got new customers, we got new demand. How do I now go rein that in? And that's where governance to me plays a big role, right? The policy as code, right? Of having that relationship with optimization as code to feed into policies, and having policies be able to go look at your infrastructure. Because as an executive, it's like, well, how bad is it, right? Like, yeah, I saw the money part, but how bad? Like, are we talking, 6 months to go reconfigure, reoptimize? Are we talking 2 years? Like, where are we at? And that's where that policies code really helps out with, hey, give me a scan. Tell me, okay, cool, got it. 1 month project and we can save, 50%. Let's execute it. That's that governance policies code coming back in.
So what I love about this, it allows these workloads to be self-optimized, or in other words, to be autonomously optimized. They're able to take care of themselves. They're able to improve their efficiency internal to the application. So it's not another process that's acting upon it. It's the ability for it to make a decision based on what it's doing, and the applications are going to know what they're doing better than any human being or other systems that are surrounding that, to make the decision in terms of how we need to optimize these systems and how we're leveraging policies to, kick these things off, and AI capabilities to, have some ability to learn as we go and make decisions based on better data and understanding the different patterns of the data. So what are some of the use cases that you see out there where this is kind of killer for optimization as code, and how are people leveraging this, and, what kind of applications are leveraging this?
The top workload, I call them the high flyers. Those top workloads are things that are in the data sector. So when we talk about databases, when we talk about, open source on the MySQL, Postgres, we look at things like MS SQL and Oracle from commercial. These are the ones that are, heavily being used in the cloud. And we've got optimizations on the shelf, and for the most case, not being leveraged completely. And so, again, another perfect opportunity. So it's like that database, right? Database. And now, how you use the database, are you doing key value pairs? Are you doing booking reservation? Are you doing, user management, for logins for websites? A lot of those use cases still resonate and hit, but it's that database where we can come in and pick those optimizations up and leverage them quickly. And in some cases, it's just, something that we've upstreamed. We have, put it in the code. It is available, but it's a question of, are you selecting the right version? Are you selecting the right version on top of the software and on top of the hardware stack? So a lot of it's that, well, what is the recipe? What is that, what is that configuration? What is that gold configuration of how to run? So database, top list. Next down is this little workload called AI, just a little one. And we look at things like, how do I do Chat GPT? How do I do it quickly? And how do I do it tomorrow, if not today? And also like Stable Diffusion for imaging, Chat GPT / Fast Chat has been top of the list of, okay, I want to do this and I want to dabble. How quickly can I do it? How quickly can I show it? And then what do I need to go fine tune the model so that I can start using it inside of my company? And that's one of those, from an optimization standpoint, it's, wow, now you're picking up part of the hardware, part of the accelerators that are available in the market, part of the libraries that have been optimized, part of the code language runtime has been optimized, and the software stack, even additionally above that, which is the UI. So those two are kind of the top flyers. So in optimization, there's got to be automation and there's got to be that closed loop. And that's one of the kind of the underpinnings of optimization as code is it's not just good enough to have the tunable parameters, but I've got to be able to set up that closed loop where my infrastructure is telling me stuff and I'm able to adapt to that. And a new phrase, but I've been kicking out this conversation around automated instance selection for how does your infrastructure pick up that real-time telemetry? How does it use it to make decisions about where your infrastructure should be and what type of infrastructure it should be on? And then it automatically takes care of that and readjusts itself on an ongoing basis. And that is truly the win at the end of the day for optimization as code is just I'm constantly learning, listening, changing, and reflecting that back without human intervention.
So where can our listeners learn more about you and also this topic in general? Where can we find more information about optimization?
Yeah, absolutely. So a couple things. I would go out to intel.com. We have our /cloud. So intel.com/cloud will take you out to our cloud tools and what we have available from our developer tools, our business tools, our different transition tools. And so you can go out there. We have, like I said, all the tools, technologies are listed there. Also, if you're interested to hear more as I dig into like automated instance selection or optimization code, is go to Cloud TV, and it's on the Intel Partner Alliance. It's a Cloud TV program, and I'll be deep diving along with one of my peers, Sarah Music, and a cloud solution architect as well. And we talk through very specific things, what the value, the benefit is, why would you want to do it, and then a little bit about the code and the technology underneath it. So join me there or jump on LinkedIn and add me, and let's talk more about optimization as code, automated instance selection, and where this is headed.
Yeah, Josh, this is a great concept because if we need anything right now, it's the ability to kind of look at this in a scientific way, in a repeatable process way. Everybody wants optimization, but the ability to do it in the proper way and the ability to build it into your systems is going to return a huge amount of value just kind of based on the fact that we're dealing with very under-optimized systems right now. They're eating too much money. They're not using resources. Here we come into generative AI and some other capabilities. And your ability to optimize these things in a dynamic and autonomous way is really going to be what's critical to the success and getting this stuff up and running and have it operating so it brings back value to the business. So if you enjoyed this podcast, make sure to like us, rate us, and subscribe. You can also check out our past episodes, including those hosted by my good friend Mike Cavas. Find out more at DeloitteCloudPodcast.com, all one word. If you'd like to contact me directly, email me at DLinthicum, DLinthicum, @Deloitte.com. So until next time, best of luck on your cloud journey. You guys stay safe. Cheers.
Thank you for listening to On Cloud for Cloud Professionals with David Linthicum. Connect with David on Twitter and LinkedIn. And visit the Deloitte on Cloud blog at Deloitte.com/US/Deloitte-on-cloud-blog. Be sure to rate and review the show on your favorite podcast app. This podcast is produced by Deloitte. The views and opinions expressed by podcast speakers and guests are solely their own and do not reflect the opinions of Deloitte. This podcast provides general information only and is not intended to constitute advice or services of any kind. For additional information about Deloitte, go to Deloitte.com/about.